Hello students, today I am going to explain some probabilistic situation to you. First, to understand how to use and when to use the additional rule and multiplicative rules. Suppose we have two events A and B are said to be mutually exclusive if they cannot occur together. For example, draw a card and find the probability the card would be a king or a queen. In this example, nothing is common. It means events are mutually exclusive. Therefore, probability of A intersection B equals to 0 if probability of intersection B not equal to 0 shows the events are not mutually exclusive. So you should remember probability of A intersection B 0 means events are mutually exclusive, otherwise not mutually exclusive. Now the next example, suppose we have two events A and B are said to be independent events if the probability of event B has not changed due to occurrence of event A. If the events are independent, then probability of A intersection B equals to probability of A into probability of B. And also you should remember that probability of A given B equals to probability of A, or probability of B given A equals to probability of B if the events are independent. Now consider problem 90. In this scenario, as you can see, we have probability of C. It is given probability of C is 0.4, probability of D is 0.5, and the probability of C given D is 0.6. Requireds are: in part A, find probability of C and D. Part B, are C and D mutually exclusive or not? In part C, are C and D independent events or not? In part D, to find probability of C or D. And our last part, to find probability of D given C. In solution, in part A, as we know that the probability of C given D equals to probability of C intersection D divided by the probability of D. Now we put the values: probability of C given D 0.6 and the probability of D 0.5, and finally we get the answer: probability of C intersection D is 0.3. In our part B, to check the given events are mutually exclusive or not mutually exclusive. From part A, probability of C intersection D is equals to 0.3. It is not equals to 0. Or you can see the probability of C given D is 0.6. It is also not equals to 0. In case of events mutually exclusive, probability of C intersection D should be equals to 0. Therefore, we can say events are not mutually exclusive. In our part C, events are not independent. Probability of C given D not equals to probability of C. Or we apply the independent rule here. The probability of C intersection D equals to probability of C into probability of D. If the events are independent, equation should be equal, but you can see the answer of the right side and the left hand side is not equal. Therefore, we can say the events are not independent. Now to find the part D. In part D, probability of C or D equals to probability of C plus probability of D minus probability of C intersection D. Here we apply not mutually exclusive rule. Now simply we put the value 0.4 plus 0.5 minus 0.3 and the answer is 0.6. In our last part, to find the probability of D given C equals to probability of C intersection D divided by the probability of C. Probability of C intersection D is 0.3 from part A and probability of C is 0.4. The final answer is 0.75. Thanks for watching. See you in the next video.